Good day, Gandalf. We're flat out doing math.
Good day, mate. This problem looks to be a cactus.
Begging your pardon, Gandalf, but we ain't buggered yet. When you add two fractions, you must have a common denominator, which is like magic. I think I'll just put on this ring. Frodo, don't wear the ring! Crikey, Frodo!
I was pretending to be a drongo. Oh, to add these fractions, you just have to get a common denominator. So if you observe over here, I've multiplied by 1, x plus 8 over x plus 8. And over here, I've multiplied by x plus 1 over x plus 1, which gives the common denominator. You little ripper! She'll be right. Just multiply out this stuff and add it up.
Crikey, do we multiply out the denominator? No, you might as well leave it.
Oh, Sam, I've multiplied everything out. And in the numerator, what do I do now?
I think, Mr. Frodo, you should just add like terms. Crikey, that's easy. Let's do that.
Begging your pardon, Gandalf, is there a way to check that we did it right? Is there any way that we can use our calculator to check? Yes. Just put in x equals 7 or some other number like that into the original and your answer. See if you get the right number. See if you get the same number. I will do it for you with my calculator. So there's the answer you have with 7 plugged in for every x. And then the next one is the original with 7 plugged in for every x. And let's see if we get the same answer. We do! We got it right. Well, that's a fair dinkum. Well, that was 2 minutes. That felt like an hour. Let's do 2 more problems. Your homework to try for next week, 8.3. Do some problems. And you guys, I'm around. I'm just sitting around with my weasel. Email me and we can do like a Google Hangout or a WebEx web conference or just a regular chat by typing in. But you can get immediate help with this stuff. Now here's what's happening. You got to be able to add, subtract, multiply, and divide fractions that have letters in them. And the one that drives everybody crazy is common denominator. You know how to get a common denominator. You just go shopping. What do I need here? Well, I need a 6. That's 3 times 2. Let's write that down. That's 3 times 2. I need an a and I need a b cubed. Now I go over here. I need a 3 times 3. Well, the 3, I have 1 pair of 3s. I have a 3 in each, but it means I need another 3 and another 2. I need a 2 over here and a 3 over here just to match the constants. So let's fix this up. Just write down the stuff you need. All right, so I need a 3, and I'm multiplying by 1, okay? I need a 2, and I'm multiplying by 1. All right, I have an a and an a to the 4th. This guy needs a cubed. Now they both will have a to the 4th. This guy has a b cubed. This guy has a b squared. This guy needs a b. Still multiplying by 1, still multiplying by 1. Now I have a common denominator. I like to write that common denominator once. And my common denominator is 3 times 6, 18, or 2 times 9, 18. Okay, I've got the 18. I've got the a to the 4th. And I've got the b cubed. Up top, 5 times 3 is 15, a to the 3rd, minus sign. 2 times 2 is 4b. And that's it. Do not cancel a b here or an a cubed here, because this division symbol is applying to the entire numerator. You have to cancel out of the entire numerator. So if you had a b cubed in both, you could cancel all the b's, but you don't have anything like that. Can I cancel out a 3 out of this 15 and this 8? No, because there's no 3 in this other term. That's your final answer. There is no simplification. And how would you check? Well, if you're that paranoid, you could let A equal 2 and B equal 3, or A equals 5 and B equals 4, or something like that. Put them in the original, do that on your calculator, then put them in here. See if you get the same number. That's a lot of typing. We didn't do that much. It wasn't that big a deal. Let's trust that we did it okay. Now over here, this guy's a lot more work. Notice it's problem 52. This guy's going to take up some space. I want to see, like over here where I had a 3 in common, so I didn't have to multiply by a full 9. I want to see if I got anything in common between these two. And I'm very suspicious that I do have some stuff in common because I see some numbers that look like they could match up. So let's see what we got. I got to have a 3x, and I got to have an x. This guy, this 6x, is trouble, isn't it? Because you got to have a 6 and a 1 or a 3 and a 2. So let's take a look at what the options are. We have the 6 and a 12 to work with, and we're only going to have 1 on the inside. So that means I need 2 pieces that when I multiply all the stuff together, it balances out. So I'm thinking if I go with a 3 and a 4, a 3 and a 2, I mean, and then over here for the 12, if I go with a 3 and a 4, 4 times 2 is 8, 3 times 3 is 9. That gives me a difference of 1. So I'd like to get the 3 and the 4 there to try and get this 1x. That means I got to get the plus on the 9x and the minus on the 8x. And check it out. When you multiply, negative 4 times 3, negative 12. Negative 8x plus 9x is 1x. And I got my 6x squared. This thing is right. I wonder if I get a 3x minus 4 over here. This is you being suspicious. Why'd they give you this problem? Why'd they give you this problem unless there was something in common for you to fish out and find? So I've got a 3x minus 4 in both of these spots if this factoring works. Well, I need to get a 4. 4 is 4 times 1. So out of plus 1 here, I get a negative 4x and a positive 3x. That gives me negative 1x. This factoring is right. So my common denominator can be written like this. And I hope this isn't so fast for you guys. My common denominator is a 3x minus 4, which they both have, and x plus 1, which the first fraction has, and then a 2x plus 3, which the second fraction has. That's the common denominator. That covers both denominators. All right, now, this x minus 3 had to get multiplied by what? Well, this fraction needed the 2x plus 3. There's a plus sign here. 2x plus 5. What did this fraction need? This fraction had the 3x minus 4. It had the 2x plus 3. It needs the x plus 1. So I'm throwing on the x plus 1. I'm erasing over here so I can work to the left. And what do I have to do? Look, never multiply out a denominator. Never multiply out a denominator. There's no reason. Because if you're going to cancel by division, you need to be able to see the factors anyway. So this denominator stays the same. The numerator, we got a lot of multiplying to do. Luckily, we're pretty good at it. X times 2x is 2x squared. X times 3 is 3x. Negative 3 times 2x is negative 6x. And then negative 3 times 3 is minus 9. Oh, I'm going to need all the space I can get for this other side. I'm going to have to write kind of small. 2x times x is 2x squared. I'm going to get a 5x plus a 2x. That's a 7x. I'm going to save some space and write that in. And then I have a 5 times 1. That's plus 5. Sorry about that, but I squeezed it in and got it in the picture. Now add like terms. This will be your final answer unless it factors. 2x squared plus 2x squared is 4x squared. 3x minus 6x is negative 3x plus 7x. Minus 3x plus 7x plus 4x. then I have a -9 and a +5. That's a -4. Wow, everybody's wearing a 4 this year. I don't think I can cancel out anything. This is a good answer. That's a good answer. The only thing you can do with it is factor out a 4 if you wanted to and have x squared plus x minus 1, which doesn't factor, which means with the 4's in there, it doesn't factor either except to pull out the 4's. So that's your final answer. And that's the kind of stuff. Please do a good 6 or 10. Get good at these things because there's more to be done. But this is where we're going next. So this is worst case scenario where you've got some stuff that factors and you do all this stuff. Now, if you want to, you can say, well, couldn't I have just multiplied the 2x plus 5 times all of this, the x minus 3 times all of this, and here's my common denominator, just this times this. Yes, but then you'll still have to factor and cancel out stuff. It's easier to factor when the powers are smaller. It's easier to factor when you can see what the pieces are. So I suggest doing this, because otherwise, if you miss canceling out the stuff, if you miss canceling out the things that are in common, it's not correct. The whole point is take the ideas that we learned in chapter 6 and 7 and apply them to these fractions with letters in them called rational functions. Okay, you guys, you got homework. See you next week.